Okay, so today we're looking at piecewise functions, and this continues from what we did on 1.5. Okay, just going to put a couple more pieces of the puzzle together. So directions, we're going to sketch. I'll write out a problem, but we're going to sketch it, and we're going to make sure we put significant points on there, not just so we're going to show significant points. Significant points. And then we'll do domain and range. Just good practice on that. Okay, so number one. So let's say our function f of x equals, so we're going to have two pieces to this puzzle. And we have this little symbol like that, or you can put some kind of bracket there, but that's usually the symbol. So let's say we have the graph y equals 3 for one of them. And we all know what that looks like, don't we? What does this y equals 3 look like? Is it vertical or horizontal? Okay, so we have a horizontal line. But we only want to see this horizontal line if x is less than -1. Okay. Does this look familiar? This is what we did yesterday, right? Or Wednesday, block day. Okay, then we have another piece. Let's say we have y is equal to 2x plus 1, which is a line, y equals mx is b. But we only want to see this line if x is bigger or equal to -1. Okay, so it's a domain restriction, just like on 1.5. Okay? All right, so let me show you the process, but let's go ahead and set up the graph like this. And here's my process to graphing these. Okay, the first thing I do is I want to plug in these points. So this -1, I'll plug it in. So now I literally write an ordered pair. So x is -1, and then we plug it in. There's actually no x to plug it in. So what's y? 3. Y is always 3. Doesn't matter what x is. Y is always 3, right? So -1, you get 3. So that's an ordered pair. And I write it there. I go to the next one. Okay, -1. So I plug in -1. And if I plug in -1, and you get, what do we get? 2 times -1 is -2 plus 1 is -1. Okay. So that's my first step. I want to get off my cutoff points, where these graphs are, because we need to plot them, right? So actually, next thing I do is I do plot them. So -1, 3. So -1, 1, 2, 3. And -1, I know we're going to need a -1. Okay, so far, we can all plug in and get points. I know we can all do that. The second thing we do is we plot, and I know we can all plot. But as we plot these points, we got to make sure if it's going to be an open circle or closed circle. Okay, so at this point, -1, 3. Are we going to plot it with a closed circle or open circle? Why open? There's not equal. It's just less than -1. Okay, so -1, 3. -1, 1, 2, 3, open circle. So that's what we do. So we're plotting points now. Okay, let's go to this one. So -1, -1. -1 there. Is it going to be an open or closed? Closed right there because it's greater or equal to. So -1, -1, closed. Okay, now we're going to graph this piecewise function. So just like yesterday. So let's go up to this. Let's do this first one. We should see this horizontal line, y equals 3. I mean, we know what it looks like. Here's my horizontal line, y equals 3. Just keeps going. This is y equals 3. But we only want to see this when x is less than -1, right? So here's -1. So should I just go like this and just keep going? Do I want to see it over here? No, I only want to see it when it's less than -1. So there's that part, just like that. So there's y equals 3 when x is less than -1. Okay, let's go to the next one. So this one, when x is bigger than -1, Okay, so when it's this side of negative 1 over here, this is where we see the graph. Well, we all know how to graph a line. How do I graph this line? Do the slope. What is a slope? 2. Okay, so how do I do the slope? Up 2 over right 1. So 1, 2 over 1, there we go. And actually, there's our upshift of 1, but there, just connect that, and there's our graph. There's our graph. Looks kind of funny, but there's our graph. Okay. So piecewise graphs are just different pieces. Why do we even have piecewise graphs? Usually this is maybe time, months, years, minutes, seconds, whatever. And so from this time back or up to this month or whatever, we have a certain equation. After this month, we switch to a different or whatever. So it's just usually related to time. But anyway, there's just two different functions there. Okay, split up by different times. Okay, actually domain range. Domain range. What is the domain of this function? Do we have an x equal, actually at negative 1, is there an x, is there a graph? X equals negative 1, is there a graph? Yes. So we don't have to worry about that. Actually, every single x, there's a graph to it. X is negative 50, there's a graph. So what's our domain? Negative infinity to infinity. Every single x value has a graph. Range of heights. What's the lowest this graph gets? Negative 1. What's the highest it gets? Infinity. Do we have to worry about this? No, because there is a height right there. And it just keeps on. This covers everything right there. That's our range. Okay? All right, let's look at another one. Okay, number 2. Y is equal to, we'll do two pieces. Okay, y is equal to x squared if x is less than 2. And 1/2 x plus 1 if x is greater or equal to 2. Okay, so, well, we have two graphs. One's part of a what? Line, exponential, what is? One's part of a, what graph? Parabola. And one's part of a line. So one's part of a parabola, one's part of a line. That's what we should see. All right, let's do the same steps here. Let's graph this thing. What was our first step? What do I do first? Plug in the points, find the points. Okay, so x is 2. We can all do this. We can all do this whole thing, but we can at least all get points. Okay, so we plug in 2 for x, and what do we get for y? Plug in 2, and we get what? 4. 2 squared, 4. There we go. Let's go to this one. Plug in 2. Well, let's plug in 2 for x. What's half of 2? Half of 2 is 1, plus 1 is 2, so 2 comma 2. So we can do that. Now we plot. Okay, so 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. Okay, so I know we can plot, get points, and I know we can plot. But when we plot, we got to make sure it's either an open circle or closed circle. So at 2 comma 4, is it open or closed? Because it's just less than. So 2 comma 4, open circle. 2 comma 2, closed. There we go. Okay, now let's just graph this. Well, let's graph this parabola first, or part of it. Again, just like I asked yesterday, if I asked you to graph y equals x squared, I know we can all do that, right? How does it shift, or does it shift? It doesn't. It starts at 0, 0, and it opens up. So the vertex is 0, 0, right? And opens up. So really, if we wanted to, we could just, okay, 0, 0, and opens up, right? Okay, we don't want to see the entire parabola. We only want to see it when it's less than 2. And it ends up at 2, 4, right there. So do we have an idea of how this is going to look? Okay, when it's less than 2, so it looks like this, this, there we go. So when it's less than 2, we see the parabola. Okay, starting to make sense? Or make sense? Okay, let's go to this one. After 2, x equals 2, we should see this line. Well, a 2 right there. Okay, so after 2, we should see, how do we do the slope? Go up 1 over 2. Up 1 over 2. There. There's that line. There's our graph. By the way, have you guys heard of the vertical line test?
Yeah.
Okay, what is the vertical line test?
It's on the line.
Okay, so if you draw a vertical line anywhere, it only crosses the curve one time. Okay, and if it passes the vertical line test, then it's a function. If it fails the vertical line, then it's not a function. Okay, so this passes the vertical line test. So as you're doing your homework, as you're doing some problems on your own here, if we had something that overlaps, let's say we had something down here and there, did the vertical line test, crosses once, crosses twice? No, we know we did something wrong. Okay, so it only touches once. Even there, because it's not there, but it is there once. So it passes the vertical line test. Question?
How does it S-shaped parabolas?
The like this, or what do you mean? S-shape means something like this.
Yeah.
Yeah, that's actually a cube, and we're gonna learn those this year. It's to the 3rd power. Okay, those little squiggly line shapes. Yes, that's a cube. Okay, so let's see. We're going to do one more together, and then the next one you'll do on your own. Okay, so number 3. Okay, y is equal to, this will have 3 pieces to it. Okay, y is equal to negative x plus 2 if x is less than or equal to negative 2. So that's a line. I know we can graph that as well. We have another line, y equals 4, which is a horizontal line. And we'll see this between negative 2, x, and 3. So between negative 2, x is negative 2, and 3, we'll see this horizontal line, y equals 4. And then the third piece, negative 1/2 absolute value x minus 3 up 4, so plus 4. And we'll see this when x is bigger or equal to 3. Okay. Well, you might be thinking, gosh, this is a lot. This looks pretty confusing. But isn't this just 3 smaller problems like we did yesterday? It's exactly that. Okay? One's a line, one's a line, one's a V, or part of a V. Okay, well, let's plug these in. So negative 2, because we got to plot these. So negative 2. So if we plug in negative 2, cross my fingers, hopefully we get this. What do we get for the whole thing? So if we plug in negative 2, what do we get? 0? 4? Which one? 4. Plug in negative 2, substitute negative 2. Negative 2 is positive 2. Positive 2 plus 2 is 4. Okay. So negative 2, 4. This we have 2 to plug in. We'll get 2 points. So negative 2. So if we plug in negative 2, nothing to plug it in, but what's y? Always 4, right? So negative 2, comma 4. There we go. Then we got to go to this one. Plug in 3. So we got another point. 3. X is 3. So 3 comma 4, because y is always 4. Doesn't matter what x is, y is always 4. There we go. And we'll plot that in a sec. So then we go to this one. Okay, 3. So plug in 3. 3 minus 3 is 0. What's the absolute value of 0? 0 times a half, so 0 plus 4. So plug in 3, you get 4 as well. Hang on one sec. Okay. Okay, so back up here, back up here. Okay, so let's go ahead and plot these. Okay, so -1, -2, 1, 2, 3, 4. We'll need a 1, 2, 3, 1, 2, 3. All right, so let's go ahead and plot. Okay, so -2, 4, open or close circle. Closed, so -2, 4, we can all plot. There's a closed. Let's plot this one. Hey, it's the same thing, -2, 4. -2, 4, it's supposed to be open, so never erase. So -2, 4, I know it's open there, but don't erase. Okay, one's closed, one's open. It's right on top of each other, so it's closed. Okay, it kind of closes the open circle, if that makes sense. So, all right, so let's go to the next point. So 3 comma 4, is that open or closed? Open. Okay, so 1, 2, 3, it's open. But wait, there's more. So this 3 comma 4, open or closed? Closed. So that actually closes it. Okay, never erase. So I actually only have 2 points. Because on this one it's closed. 3 comma 4. This closes it. Okay? Okay, so now let's go ahead and sketch this. All right, so we should see a line, a horizontal line, and part of a V. All right, so let's look. When x is less than -2, so over here, when x is less than -2, we should see this line. It has a negative slope to it. So how do we do a negative slope? Down 1, right 1. So should we do that? Down 1, right 1, down 1, right 1. Should we do that? Why not? Because we want to see this when x is less than -2. We want to see it this way. So how can we do a slope of -1 but going this way? Up 1, back 1. +1, -1. Okay, so up 1, back 1. There we go. And there's the first graph of the 3. Okay. Does that have a negative slope to it? Sure. Left to right it drops. We're good. I like these because all we have to do is connect the dots. What are we going to connect the dots with? A horizontal line. So there we go. Y equals 4. Okay. Okay, now going to the third one. When x is bigger than 3, we should see this V. Does the V open up or down? It opens down. So do the slope. Okay, so it looks like this, right? It looks like this. But we just want it when it's bigger than 3, so we want this side. So we go down 1, right 2, 1, 2. And so there we go. And there's your graph. Okay, go. Okay. Domain and range. Domain and range. Um, perfect. Okay. So domain and range, all the x's are covered, so negative infinity to infinity. And the range of heights, this goes down forever, it goes up forever, so negative infinity to infinity. There we go. Okay, last one. I know we're going to go right to the, almost to the bell, but number 4. So y is equal to x squared minus 3 if x is less than or equal to 0. 1x if it's between 0 and 2. And then negative x squared if x is bigger or equal to 2. Okay, so I want you to follow the steps. Yep. So do the first step, which we all know what to do. And we'll get as far as we can here. Get out at 58. We'll be able to finish this. No problem. Okay, so get your points. Plug in 0. We can all do this. We can all plug in and get points. Plug in 0. Get your points. And I know we can all plot. So we plot. Just determine whether it's a open circle or closed. 0, comma, something, right? And then plot those points. Plot those points. Start back. Question? Sure. And then plug in this one. Plug in 2. Root this is plug in 2, get negative. Okay. Okay, so let's see. 2, 4, 0, 0, 2, 2. So this one, 0, -3, we should see part of this one around it. Okay, so that's that. That looks correct there. And then this one's okay. Yep. Okay. So for sake of time here, let's get our points. 0, comma what? -3. This one's 0, comma 0. And then plug in 2, and for x, 2, comma 2. And plug in 2 here. Let's make sure we get this right. If we plug in 2, we get what? -4. 2 squared is 4, then times -1, so -4. So we plot 0, 1, 2, 3. That's a closed circle. 0, 0 is open, and 1, 2, comma 2, that's open. And then 2, -4, this is 2, -1, 2, 3, 4. This is closed. Like that. Okay, so we got them plotted. Now we graph it. All right, so when x is less than 0, we should see a parabola that opens up. it's shifted down 3, but we're here. It's 0, negative 3. And when it's less than 0, okay, so there's that. Okay. Between 0 and 2, x is 0 and x is 2. We should see a line with a up 1 over 1 slope. But just connect the dots. Connect the dots. There's y equals up 1 over 1, up 1 over. There it is. Okay, and then after 2, we should see a parabola that opens down. And I know it's at 0, 0, but I'm not going to put 0, 0 there because I want it after 2. So I could graph it like this. I know what it looks like. Goes boom, hits right there and comes down. But I just want this part of it, just like that. Looks kind of weird, but that's it. That's it. That's part of that parabola, bigger than 2. Okay? Okay. Your assignments, the next thing on the packet. Hopefully we'll get most of it, but we'll definitely go over it on Tuesday.